Okay, now the first thing I'm going to do is to remove the lead of the back socket using soldering. You just want to remove everything. You remove everything. You start your connection afresh. So before you fix the wires to the terminal of the socket, you solder it first. As you can see, I'm soldering it. Then you also solder the terminals of the socket. Solder it one by one. You solder it to make the plate, the surface hot. If not, if you say you connect the wires directly, know how it will never be soldered. So carry over and you solder it. Okay, as you can see, this terminal is a iron, it's not a copper, so it will not hold, it will not solder. So what you need to do is to tighten it. As you can see, I've tightened it now. You tighten it, and this is our neutral. Take note, neutral from the supply, direct neutral from the supply. Okay, please be careful. This stabilizer is a very risky something, very dangerous something. So the another side is the live, not direct from the source. Take note, the other side I show now, this side now is not direct from the source, but it is live. This video I will still show you where I will connect it later on. So you can see neutral goes everywhere in stabilizer. It enters the output socket. Neutral is the same supply neutral that enter the panel, enter what is it called, AC meter, many of things. So as you can see, the neutral, I'm tying it with the supply. This is the supply neutral, the supply cable. As you can see, neutral. Then I'll see tie another cable again. Now I'm just soldering it. After I tie this one, after I solder this one, now I will still attach another one that will go to the panel. So let me look for a wire. That's the neutral side, right? Okay, that's the other panel that we are not using. We are not using this panel. We will remove everything from that panel to the new panel. Okay, now let's leave that part. Let's read the switch, the principal working of the switch. Yes, as you can see, the up, this switch have 4 terminals. We are using only one side. You can see the switch is working. We are using only one side. Don't solder it. You can solder it there, you can still solder it at this part if you like. But one wire will be up, another one will be in down. As you can see, it's not continuity with that side. It doesn't have continuity with that side. So the direct live from the supply will be the one that will go to switch, not the neutral. You know, the neutral is the one that will loop in the socket, output socket, and it will enter panel, but not this front switch. The front switch you see now, direct from the live supply, direct supply. The live will be the one to enter the switch. So you can see the live doesn't go anywhere, it's direct from the supply. So I sold one wire there, I sold one wire here. See, it has sold because this one is stainless something, lead can easily catch it. So that is the other side, the other output of the switch, direct from the supply, and it is live. So you can see the output now. Then inside the, if you trace panel, you are going to see where they write in L. That in L mean input live. My camera cannot view it very well, but what is written there is input live. Some panel they will just write only in, no live. So that's where you. So I've connect the live, the in live, from the output of the switch, of the front switch. Okay, you solder it again, because soldering is a very powerful something. If you need solder it will be having partial contacts and it will lead it to its damage. So I isolate it again. That's how it is being done. So you can see the inlet. Then what I'm going to do now is the remaining inputs of the stabilizer. Okay, the neutral, right? Okay, I tell you the other time that I will connect another neutral to that one. That one will be the one that will go to the panel. Yes, as you can see, the neutral, I feed the input neutral with that other socket. So you can see it, I feed it. So now you connect another wire to that neutral base that will go to the panel. You solder it. Then you connect it to them. So now you can say I've connected them from the input neutral, feed it with that socket, and then take it again to the neutral. So from the panel, they have where they label N, only N. That N mean neutral. You look for it, and at the same time it also serves as a ground. Okay, but just let's finish here. The neutral. So now I found my neutral port. Now I will connect, I will solder it to that neutral place, because without neutral there's no how the panel will function. It won't function if there's no neutral connect to it. Connecting neutral. The soldering is very low, it's not hot very well. The temperature is not high, the voltage is too low. So that's the neutral port. So we only put neutral in and live in. Now remain those other cable that we are going to remove from. Okay, as you can see, there are still remaining other ports. I will desolder them using socket so that we have a way to attach, to connect the cables to the transformers. And be mindful, you know, transformer coil, most of them are aluminum, so you can't solder it directly to this panel. All we need to do now is to connect cables, short cables to these terminals now. And after that, we'll be connecting it to the transformer coil since it's aluminum. So you see, I've desoldered the ports to enable me put wires, solder it. I'll start with I'll look for a piece of wire. I see I'm putting on, then solder it, yes, I solder it now. Now look on that cable again, you insert it to the port and solder it. Apply the same method in all the ports. And these ports are labeled, some panel they are labeled A, B, C, D, E. Some panel are labeled 1, 2, 3, 4, 5. But this panel, the label is A, B, C, D, E. So I will teach you how to connect the transformer coil now to the panel. You look for it. Seems we have already put our in lab and neutral. Now what we need to do now is to look for A, label A. They doesn't follow each other with ascending order or descending order. The numbers are scattered. So we'll look for our A. After we solder all this port, now we'll look for our A. Peeling the edge with soldering. Peeling all the edge. So now I will read from that panel. I tell you guys that we are going to put a capacitor. There's 1 bar capacitor. So I will desolder that hole. Okay, the capacitor is broken, right? Yes, the capacitor is broken. So I will remove the solder. I will desolder that place to enable me to put another one. So let me put it. You can see. Be mindful, this is a DC capacitor. You have to look for the polarity. If you interchange it, it won't work. So you have to make sure the polarity is well aligned with the panel on. Mostly the DC, the ground of the capacitor is always shaded. They used to shade it, and even the panel, the ground side is always shaded. So now I've put it, I've soldered it. Solder it. Then I will read. I read all the to make sure the transformer is working fine. You can see all is reading. Even though one does not read, that transformer has a problem. It must read all but different ohms. As you can see, that first one give me 14 ohms, the remaining one was giving me 001 ohms, 002 ohms, 003 ohms. So that 14 ohms is 18 volts. The bell, its level, okay, this one now is my label A. You start from top of the transformer coil. How they are arranged from the up, you count it A, B, C, D. So that is A. As you can see, the coil, you start from up. Your up one is A, followed by B, followed by C, followed by D, followed by E. Then if you carry the first one, which is A, you look for its label in the panel of A. So you can see that is the up on is A. Now I fix it in a port A. The second one is B. I'm connecting it in ascending order so that you should understand very well. So followed by that one, and that one is B. So I will lose it. In case you are asked to connect stabilizer, you are asked to install new panel to stabilizer. The same thing that you are going to do to it. As you can see, the coil is two. You make sure they touch very well, because transformer coil, stabilizer coil or transformer coil, they are looped. They are looped with each other. So that too, if it does not connect with each other very well, then the continuity will not pass them, will not pass to the remaining one. So you will make sure you twist it very well and solder it, followed by insulating it. Then you prevent it from touching with another place, damaging the stabilizer. It's too tall, so I cut it to enable my work should be neat. So I've connected the port B, right? That's B. Please be careful connecting the transformer output here, because if you made a slight mistake, then the coil will be burnt. Then that one is my C. As you can see, it's also 2. And make sure I tight it very well. And that's my port C. Right, yes, that's my port C. I connect it very well. Make sure I twist the 2 cable to enable the continuity. So I use sellotape it too, using black tape. Then we are done with A, B, C, then followed by D. Here I tell you, from the transformer is ascending up A, followed by B, followed by C, but from the panel it is scattered. It's not ascending or descending, it is scattered. It might be from last place. As you can see, this one A is from the middle. Then that's my D, which is last. This D is in the last place. I'll solder it again. And if you didn't solder it, you discover some stabilizer, you'll be hearing some spark inside. This is where the problem always come from. You tape it. Don't say, no, all this sellotape is a rubbish thing, I'll just do it. It will cause fire hazard. I'm done with A, B, C, D, right? Then followed by E. Yeah. As you can see, it's remaining 2 now. Some stabilizer, they used to name their own F10. Some they'll just write only F. But that 2 is 18 volt. That 18 volt have where it's used to. Inside that 2, you discover that inside that 2 that I have not removed from that panel, one slot of coil. The only one that is inside is only one stranded one. Then the other one is 2, as the remaining ones now is 2. They inside that one. That one that has only one stranded coil inside will attach to the neutral. Please, you should listen to this place very careful, because if you made a mistake, stabilizer will got burnt. In fact, fire hazard safe. So see, everywhere is already occupied. Then from that one now, you can see I'm touching it. Which one is only one? This one I can even lose them 2, doesn't matter. As you can see, that one is 1, that one is 2, and the one closer to me is only 1. So now let me read the stabilizer. As you can see, it has started reading already. You see, it has started reading. Okay, let me off the switch. Let me see whether it will read. I've off it. Now let me read it. As you can see, it doesn't read anything. It doesn't read anything. If you off it and it read, that means you have a problem somewhere, either from the switch or from where you connect to transformer. As you can see, when I off it, it will stop reading. The reading will give you from 0 to 30 ohms. When you put it in continuity or without, it will not pass that range. But if you give you 0, 0, 0, if you plug it, either it will be humming sound or the fuse will got blow. Should be able to give you like 0.05 ohms, 6 ohms, 7 ohms to 30 ohms. I see. Off it, on it. You see, like this one now is 0 for something ohms. Shouldn't just read like what is 100 ohms or 20 ohms. Now I've put it in lights. That's the neutral. Okay, see this one is giving me 200 something ohms, 270 ohms, 203, 280 something ohms, 300 ohms, and 300 volts. Sorry, volt. They are only volts. Now we are reading in volt, right? Volts. So now I need to connect the phase. So you can see all the phase, the cables have cut out. Okay, sorry, that one is the switch, the delay switch and on delay. If you like, you connect. If you like, don't connect it. It doesn't, it's not necessary very well like that. Unlike this one, but I connect it. Connect this. It doesn't have polarity. Either you interchange it or what will happen. It's just a switch. I'll put in the one. The main work is from the LED, the light. This is not a big deal, but the LED is the toughest one because that one have data, 5 volts, ground, CLK. That CLK is clock. Everything that have phase, all those DVD, your home theater phase, your MP, all of them have that clock. CLK is clock. It's clock data. So I will trace the label from the LED to the main board. If you see 5 volts, you connect 5 volts to it. Yes, I'm losing the paste now where the LED is at. Because if you made a mistake here, the LED is not going to on. This is the LED. So now I need to desolder those leads using my socket. So I've started soldering them to enable me install another wires. I'm desoldering them. So you can see I desoldered it. This is the port, the plug. Yes, I've inserted to the port. Yes. If you look at that port, you see 5 volts, ground, CLK, data. You won't be able to see because of the camera. It's too small. Oh, that's how you follow the phase. You see, I'm following it so that I should know where the 5 volts start from. Yes, that's my 5 volts. Then from the phase, I will look for my 5 volts. But mind you, some stabilizers, they don't used to write the label. All you need to do is trace the bulbs. Which one is plus? Unlike me, even though it's written or it's not written, I know where all I will connect them. But as a beginner, you have to look for the labels and other things. As you can see, that's the 5 volts. So you put your 5 volts to the ports. Unlike this phase, it's not labeled. Most of the phase are not labelable. All those DVD, home theaters, their phase are all labeled, but this one is not labeled. You are going to figure it out by yourself. Yes, that's my 5 volts. 5 volts are always from the LED. LED have 5 volts and ground, right? then you look for the 5 volts. If you want to know the 5 volts of your bulb, of your LED, if you look inside the bulb, you see there's a two conductor inside them. One is very slim and the other one is very wide. That wide one is ground, that slim one is your 5 volts. In case if you don't know how to use meter to know the 5 volts or ground of the LED. So now this is my cell key, which is clock timer. So I will also look for it. It's also like 5 volt too, but it's a signal. So I will look for it and insert it. I've got it. And you saw that the soldering gap is very close to each other, so you make sure there doesn't short circuit. It doesn't short circuit yourself. Then I'll look for my data ground and other things. That's how I will fix it. After you connect all the faces, then you tie it. Then the meter of the input and the output. The input meter is connected directly to the supply, which is after the switch. Then the output switch, the output meter, one leg is connected to the output of the stabilizer and the other leg is connected to the neutral as well, and the second one to the neutral. So you can just feed the neutral of the meters. And then from the transformer, we just connect remaining one leg left. The remaining leg is connected in a rectification diode. You see the port, it doesn't have polarity. You can put it at anywhere. Once you put it there, you feed it with neutral. Some of the stabilizer you don't need to feed them with neutral, but this stabilizer you are going to feed it with the neutral. So let me show you the video of it. So now I will connect the output live that we leave before. We connect it now. In some panel they will write out L. That's where you see it. I have not connected. So I will connect it now to the out live. Panel. So that's my out L. So I've already connected the to that output meter. Neutral, it have two terminal. One terminal will be connected to neutral, then the other terminal will be connected to that out L cable. I've already connected. Yes, now I want to connect the input meter. I'm connecting the input meter now. The two meter, you are going to loop their neutral.
That's the in life. I will connect it after the switch. If not, if you connect it before the switch, as soon as you plug your socket to the you plug to the your stabilizer plug to the socket, the input meter will read. So you are going to connect the meter to the output of the switch, so that even though you put a plug, if you have not on it, the meter will not turn. And I've also connect my bulb to the port. So now let's on it now. Yes, I've not put the neutral. I've not looped the neutral of the 2 meter. I need to loop the neutral to enable the meter to work perfectly. So that's the output, that's the input meter. The up one is the input and the down one is the output. So I will loop the two neutral together. I'm looping it as you can see. Yeah, solved it. Yes, you can see the bulb has on and the 2 meter has raised up. Let me zoom it for you. You can see. Let me off it now so that you should be able to see it. Yes, as you can see. You can see. One is 220 volts and the other one is getting to 300 volts. But it doesn't reach 300 volts. So I'm offing it. Now I need to package the stabilizer, tie the LED and do the necessary things. You make sure you on it, off it very well in case if there's any trouble somewhere. Yes, now I will tie the LED to its base. So the stabilizer is humming sound, so I will type the transformer very well. I have moved the sound, if not you will be hearing home sound. So if you are tight now, it will not be making that sound. In case if someone brought stabilizer to you that is humming, is vibrating, you only tight the transformer. So now as you can see, I'm tying it very well. You discover that some stabilizer, if they are working, there will be a humming sound, and some is very silent. You will not even know that stabilizer is on. So the fault is from that place. Just tight it very well. You know, in your theoretical aspect, is all know that transformer is the principle. Use the principle of induction, right? You not tight very well the induction. Maybe making the format to be vibrating. Now it's working perfectly with a silent sound now.
And at the end we'll be able to finish the stabilizer. As you can see, we on it, giving us 220 volts, and the output is giving us close to 300 volts. That means this stabilizer is a step up stabilizer. You can use it for fridge and other things. Yes, but if you have a stabilizer that's giving you like 220 volt and still give you back 220 volt, doesn't do anything. So it's supposed to increase the voltage for you. Yes, that's why we call it stabilizer. Thank you.